Hello, and today we're looking at the topic of highest common factor, which is also known as HCF, of a set of numbers. First of all, we need to be quite conversant with writing numbers as a product of their prime factors. Now that sounds really complicated, so what exactly does that mean? If we take the number 36 for instance, 36 can be written in a number of ways. The easiest way to what two numbers multiplied together gives you 36 would be 6 and 6. What numbers multiplied together would give you 6 would be 2 and 3. Again, 2 and 3. So 36 written as a product of its prime numbers is 36 is equal to 2 times 2 times 3 times 3. Now if we take the number 42 and write it as a product of its prime factors, we would look at the numbers that we use to multiply, would be multiplied together to produce 42, which would be 6 and 7. 7 is a prime number, so we stop there, but 6 can be broken down into 2 and 3. So the prime numbers that produce 42 as their product is 2 times 3 times 7. To find the highest common factor of 36 and 42, we have to do a matching exercise looking at their prime numbers involved in each of them that are used to make prime factors that are used to make each number, as being underlined here. So I like to use a red circle. Here there's a number 2. Sorry, I changed my tool. Pen. There's a number 2, and there's a number 2. Here there's a number 3, and there's a number 3. So both of the numbers have the prime factors 2 and 3. There's another 2 here and another 2 here in the number 36, but these are not matched with the number 7, so we don't count those, we cross them off. So what we're left with is 2 times 3, which is equal to 6. And we find this in both numbers, both in 36 and in 42. So we can say that the highest common factor for 42 and 36 is equal to 6. Another example we have is to find the highest common factor, the HCF, for 50 and 80. So we use a similar method that we used previously. Find the prime factors for the number 50. Well, the easiest way to factorize 50 will be 5 times 10. 5 is in fact a prime number, so we stop there, but we can factorize the 10 down further, which is 5 times 2, and we stop there. If we look at 80, easiest way to factorize 80 would be 8 times 10. We can factorize the 8 to be 4 times 2. And we can factorize the 4 to be 2 times 2. And we can also factorize the 10 over here to be 5 times 2. We then do a matching exercise looking at both numbers to see what factors are common to both numbers. Over here we have a 2, so we circle it, and over here we have 3 2's, but we just circle one of those 2's. Over here we have a 5, and over there we have a 5. This 5 cannot be matched, so we cross that out. This 2 cannot be matched, nor can this 2, nor can this 2. So HCF in this case is equal to 5 times 2, which is equal to 10. That was a pretty straightforward example. For the next example, we want to find the HCF of 45 and 99. We use exactly the same method, just the only difference is that this time the numbers are slightly bigger. So we factorize 45 as being 5 times 9. 5 is a prime number, so we break down the 9 further, which becomes 3 times 3. So those are the factors of 45, prime factors. We move on to the 99, and we can factorize that as 9 times 11, and we factorize the 9 as 3 times 3, and we can't factorize the 11 further because it is also a prime number. Then we do our matching exercise, and we find that we have a 3 here, and a 3 there, and a 3 here, and a 3 here. We can't match the 5, and we can't match the 11. So the HCF of these two numbers is 3 times 3, which is equal to 9. That was quite straightforward. So let's see if we can do something now with even larger numbers. What do you do when you have to work out the HCF of two numbers that are quite large and do not fall into the times tables of 12 up to 12? In this example I'll show you. Right, we've got 216. Now 216 is an even number, so I would like to divide it by 2 initially. So do 216. You can do long division on the side here. 2 into 2 is 1. 0. Bring down the 1. 2 is 0. Into 16 is 8. So you got 2, you factorize 216 as being 2 times 108. 2 is a prime number, so how can you split up 108? If you know your times tables, you know that 108 is 9 times 12. You can factorize 9 as being 3 times 3, and you can factorize 12 as being 3 times 4. And then you factorize the 4 down further. So those are all the prime factors of 216. Now we do the same for 240. We factorize that, and this a lot easier. We can do it as 24 times 10. Factorize the 10 as 5 times 2. We factorize the 24 as 2 times 12. We factorize the 12 as 4 times 3, and we factorize the 4 as 2 times 2. And then we do our matching exercise. We have a 2 here, and we have a 2 here. We have a 3 here, and we have a 3 here. We have a 2 here, and we have a 2 here. We have a 2 here, and we have a 2 here. This 3 is not matched. This 3 is not matched. This 5 is not matched, and this 2 is not matched. So our HCF for 216 and 240 is equal to 2 times 2 times 2 times 3, which is 8 times 3, which is 24. So the highest common factor of 216 and 240 is 24. Because 24 times 9 is 216. Okay, our last example is quite a challenging example. The numbers involved are much bigger than we've used previously. What is the HCF of 156 and 234? Now I want you to try this by yourself. I'll give you some time, and then work through it on a bit of paper, and then see if you've got the answer correct. Okay, here is the completed answer with the full working out. How did you do? I hope you managed to get most of it right, or if you didn't get the exact answer, I'm sure by seeing the worked example now that you can follow along with how to get the correct answer. So if you didn't do very well this time, just try again and work through it, and I know that you'll totally crack it. I hope you found this tutorial really useful. As long as you understand the basic principle of how to do HCF questions, all you need is just to practice, practice and practice. Until next time, bye.